You probably don't know how small an atom is. I thought I did, but I did not. I want to show you. One of the most convenient units of measurement in the world is called a mole. When you say a mole, it's like saying a year or a dozen. We all know a year is 365 days. If we stop to think about it, 366 days in a leap year, but usually we don't need to. I say I'm 53 years old, and no one ever asks or needs to know how many days that is. Likewise, you probably wouldn't say, "Could you run to the store? I need 36 eggs." You'd say 3 dozen. A mole is 602 sextillion, 214 quintillion, 76 quadrillion. Most often written as 6.022 times 10 to the 23rd. If you're unfamiliar with scientific notation, it means science is hard enough. I'm not going to write down this whole number every time. It's essentially a 6 with 23 zeros behind it. Why would anyone want to use a number like that? Well, atomic masses are tiny, and no one uses the world's smallest tweezers to put atoms together piece by piece. Overwhelmingly, we deal with grams and kilograms of stuff. So a few million atoms here or there hardly makes a difference at that scale. At some point, scientists decided that 1 proton or 1 neutron weighs 1 atomic mass unit, or 1 AMU. Compared to those heavier particles, electrons hardly weigh anything, and that makes it easy to say, okay, oxygen typically has 8 protons, 8 neutrons, so it has a mass of 16 AMU. Hydrogen usually just has a single proton, so it weighs 1. So this is where the mole comes in and makes everyone's lives easier. If you add up the atomic mass units of the substance you're working with and you multiply it by 602 sextillion, 214 quintillion, and 76 quadrillion, you get the mass in grams. That's a mole of stuff. For example, water is H2O. So we just learned that hydrogen atoms have an atomic mass of about 1, and oxygen atoms have an atomic mass of about 16. So 1 times 2 plus 16 equals 18. If you have 602 sextillion, 214 quintillion, 76 quadrillion water molecules, you have about 18 grams of water. That's an amount we can get our hands on. The other thing you know is that just like a double cheeseburger has 2 patties, a mole of water has 2 moles of hydrogen. If you're trying to make ammonia, which is NH3, instead of starting with how many grams or what volume of each element you need, you know that each molecule will have a nitrogen atom and 3 hydrogen atoms. So you'll need a mole of nitrogen for every 3 moles of hydrogen. Having done only an introductory chemistry course, I can tell you without even looking, that's about 14 grams of nitrogen and 3 grams of hydrogen, or 22.4 liters of nitrogen and 67.2 liters of hydrogen at a standard temperature and pressure. Having a mole makes chemistry so much easier. Imagine having to tell people how old you are in seconds. You can figure it out if you need to, but you won't put that on your Tinder profile. A year is a much more helpful way to talk about your age, and a mole is a much more helpful way to talk about enormous amounts of tiny things. And it works the other way. You can weigh some known element or compound, divide the mass by 6.022 times 10 to the 23rd, and that's how many atoms or molecules there are in the stuff. Let's take a breath and appreciate how amazing that is. Okay, I promised I would show you how small an atom is, and we're going to do that by imagining the size of that number. Our brains are not designed for huge numbers, but we're creative, you and me, and I think we can do it. If you stay with me till the end, I think you'll feel part of something extraordinary, because we are. A teaspoon is about 5 milliliters, and I put 4 teaspoons of water in this shot glass. Let's call that 18 milliliters for the sake of argument. One of the great things about the metric system is that a milliliter of water at any reasonable temperature and pressure is about a gram. So here's a mole of water. Now imagine the Milky Way galaxy. There are about 200 billion stars in our galaxy, and it seems that the Milky Way is an average galaxy in our universe. Now keep that picture of the Milky Way in your mind with all those hundreds of billions of stars. There are 5 times as many galaxies in the observable universe as there are stars in our galaxy. That means as far as we could ever see out to the ends of the observable universe, there are about 1 trillion galaxies, and on average, 200 billion stars in each one. That's 200 billion trillion stars in the observable universe. If you multiply that number by 3, or imagine 3 universes, you'll have a mole of stars. That's about the number of molecules in this shot glass of water. If a bartender poured you a shot like this, you'd complain. Yet it contains 3 universes. But we're not done. One more thing. If you multiplied that number by 3, because H2O, or imagine 9 universes full of all those galaxies, you'd have the number of atoms in this parsimonious drink of water. It's barely more than a sip. That's how small an atom is. Bottoms up. Don't forget to subscribe and share this with your friends. It's free to read, free to listen to, free to watch, however you take it in. Thanks so much. We'll see you next time.